Here is conditional probability and the general multiplication rule. So what this part is conditional probability. We have probability of F depending on E. If you remember on the previous section, we had two independent events, and when we have two independent events, we only need to multiply the probability for each one. But when we had dependent, so this is for this part, but I already had this in previous section. So probability of E and F, this is when two events are dependent. Probability of E multiplied by probability of F. See, we already have this part. Now having this event, second event, that depending on what we got on the previous step. So using that one, we can find this. That is probability of F dependent on E, that is equal to divided by probability of E both sides. Okay, so this is what we have. And that is also here on this part. So we have exactly the same thing. I only showed you how to find it based on when you have two dependent events. Okay, now example from number 1. Now suppose that a single card is selected from a standard 52 card. What is probability that the card drawn in is a club? So what is the probability of having club? Now suppose that a single card is drawn from a 52 card, but we are told that the card is black. What is the probability that the card drawn is club? So first, the first part is how many we have in total for club. We have 13, and how many we have in sample space. How many cards we have is 52. So that is equal to 1/4. Now next part, finding probability of club when we know that that card is black. Divided by probability of black. That's equal to how many club cards we have that are black. We have 13. All of these are black. And how many black cards we have in total? Here in total cards we have sample spaces 52. 26 of these are red and 26 are black. So the answer is 1/2. This one is 1/2, and that one was 1/4. Okay, I already covered this part on top. So we have probability of F depending on E is equal to, on top we have and, divided by what you have here on this part. Depends on what, so depending on E. So here, this one is exactly the same as that one. This is probability, but here we have the numbers that we can have here. So a number of elements that we have. Now example number 2, a survey was conducted. Here we have 1,017 adult Americans were asked which of the following statements comes closest to your belief about God. You believe in God, you don't believe in God, but you do believe in a universal separate or higher power, or you do not believe in either. So we have all these three, and these are data based on what we have here on left column. We have East, Midwest, South, and West. So the results of survey by region of the country. We have that. Now part A, what is the probability that the randomly selected adult American who lives in the East believes in God? Who lives in East. So this is given. What is given? And this is what question is. If someone who is living in that part is that person believing in God? So this is question. What I'm going to write here is probability of, first I have that question. So believes in God. And we already know that that person is in East. On this part we have what is given, and this part is our question. Now on top we have probability of this part and that part. So believe in God and lives in East. I already write East. So that's enough. Now denominator probability if that person is in East. Now we want to find the answer. Here is believing in God, and this is East. What we have in common is 204. And remember that I said when we have and, meaning that intersection, so it's this symbol intersection, and that means find what you have in common is 204. And we should find how many people lives in East. So for that part, probability of East is, we should add all these numbers. Add all these number of that part, 204 plus 36 plus 15, we have 254 and 255. So this is 255 in denominator. That's what we have for total that we have for the East. And that is 0.8. Now, part B, what is probability that a randomly selected adult American who believes in God lives in East? So now, this one is given, and this is question. So probability, this is our question. And this is what given part was. So that is equal to, now intersection between these two, again we have 204, so same thing. Now denominator is believes in God. So what you have on right, that is in denominator. Believes in God, we should add all these numbers. And that is 787. So divided by that number is total number that we have here for this part. and it's equal to 0.26. Number 3, for the month of June, in the city of Chicago, 37% of the days are cloudy. So 37 days are cloudy. Also in the month of June, in the city of Chicago, 21% of days are, okay, here is cloudy and rainy. Now after that, what is the probability that E randomly selected day in June will be rainy? So here we have rainy. Okay, so find this probability when it's a rain. Okay, probability of rainy when it's cloudy. Rainy if it's cloudy. Divided by cloudy. For this part, we have 21% of the days are cloudy and rainy, so this is 21%. And denominator we have probability of cloudy is 37%. But this was easy to find. And the answer is 0.568. Now next part, general multiplication rule. I also covered this in the first step. Yeah, from that part we got this part. And I said that when we have two dependent events, E and F are dependent, we're gonna have this instead of having P of E multiplied by P of F. Because here this F depends on E. So we have that part here on this part. Now example number 4, suppose that you just received a shipment of 6 televisions. So we have 6 televisions and 2 of the televisions are defective. 2 are defective. If 2 televisions are randomly selected, compute the probability that both televisions work. What is the probability that at least one doesn't work? So what we have is how many TV we have is 6, and how many are defectives are here is 2. That means that 4 of them works. So compute the probability that both televisions work. First, work on this part. We have that one. Probability of the first one work, and second one also works. So that is equal to probability of the first one works multiplied by probability of second one work if the first one work. Okay, so we have this one first, then the second television depends on what we have on the first one. So that is equal to, in total, how many TVs we have is 6. How many TVs we have that works is 4, multiplied by. Since here these two events are dependent, the first TV depends on the second TV, or second TV depends on the first one, depending on which way we start. So obviously we're starting from the first one and then choosing the second TV. So here, second television depends on what we had on the first try. Okay, since I have this one, now I should subtract. So we already have one TV. So we should subtract that one TV from this part. Eliminate that one from that sample space. Now we have 5. And here also, since this is work, now instead of having 4 TVs that working, we have 3 in total. So I subtracted 1. On top we have 12 divided by 3, simplify. The answer is 0.4. Now next part, what is probability that at least one doesn't work? So at least one doesn't work is 1 minus probability of all work. In this case we have 2 TVs, so we tried these 2, so both work. That is 1 minus what we got here is 0.4. The answer is 0.6. Number 5, suppose that 2 cards are randomly selected from a 52 card. What is probability that the first card, so first card is king, and the second card is king, if the sampling is done without replacement? What does that mean? Here, exactly the same as this one. Without replacement means when I had that first TV, I didn't replace that one again in that sample space and then try to choose the second TV. When you pick that TV, you only need to subtract 1 from your sample space, and then after that try to choose the second TV. So that is what means without replacement. So we're not replacing that to our sample space. Okay, now here we should find probability of king and again king. Sample space is 52, and in total we have 4 kings multiplied by. So after choosing that one, since this is without replacement, I'm not replacing that again into our sample space. So now I have 4 minus 1 is 3, and 52 minus 1 is 51 for second try. Now multiply, we have 12 divided by 2652. That's equal to 1 over 221. Okay, that's the answer. Now here we have bit replacement. What is probability that the first card is king and the second card is king, but the only difference here we have is this part is with replacement. So we have the first one king, second one again king. Now they have this part exactly same. Multiply by. Now second try, since we have to replace this, because this is with replacement, we have to replace that one It's like, okay, choosing that first card to have king, I got that king, and then replacing that into our sample space, which is 52 card deck. Again, we have 52 cards in total, and again we have 4 kings. Okay, here is one over 169, and the answer is 0.006. Now, next one, suppose that a compact disc you just purchased has 13 tracks. Okay, after listening, you decide that you like 5 songs, meaning that you dislike 8 songs. With the random feature on your CD player, each of the 13 songs is played once. So played once. Since we have played once, this is without replacement. Find the probability that among the first 2 songs played, part A, you like both of them. Would this be unusual? So what we have here is how many songs we like is 5. Dislike is, in total we have 13, so 13 minus 5 is 8. So add these two, we have 13 total. Now here is you like both of them. So we have like and like. And this is without replacement. In total, how many songs we have is 13, and how many we like is 5. Multiply by, since this is without replacement, we should subtract 1. So this is 12, subtract 1 is 4. So whenever you have without replacement, you should subtract 1 from both numerator and denominator that you got on the first step. If it's not without replacement, then you're not subtracting. So here is 5 divided by 39, and that is 0.128. And it's asking if this one is unusual. Remember, we should compare this with 5%. And this is not less than that number, meaning that this is not unusual. I'm not writing if this is usual, so because it's asking if this is unusual or not, that's why we're writing not unusual. Part B, you like neither of them. So is this like and? You can use comma or you write and. Dislike. In total we have 13. And how many we had for dislike part is 8. Multiply by, again, as without replacement, so subtract 1, both numerator and denominator. Okay, so that is the answer for part B. No, part C. You like exactly one of them. So here what we're gonna have is that you like exactly one. So we may have this like, dislike, or we may have dislike, like. So this is what sample space is. Like, dislike, dislike. And it's asking for exactly one of them. You like exactly one of them. So we have exactly one. You like that? And exactly one. You like that one? This is not exactly one because we have two likes. And here we don't have like. So we have two of these. So using that, we have probability of like exactly one. That's equal to 1 minus probability of. So instead of working on that part, I'm going to work on these two and subtract from 1 to get the answer for probability of these two. So probability of dislike both or like both. One minus from previous part B, we know that the answer for dislike and dislike is 14 divided by 39. I'm using that part. When you have or in between, meaning that you should add, and like both is 5 over 39. See, we already have these two, that's why I use this one. That is equal to 1 minus 19 over 39, and that is equal to 0.513. Now number 7, a bag of 30 bulbs purchased from a nursery contains 12 red, 10 yellow, 8 purple. So we have red we have 12, yellow is 10, and purple is 8. So we have these. Now part A, what is the probability that two randomly selected bulbs are both red? Probability of red and red. Okay, so how many reds we have is 12. And in total we have 12 plus 10 plus 8. So total we have 30 here in denominator, multiply by. So this is a bit of a replacement. So So we have to subtract that one. We have 29. So after choosing each one of these bulbs, obviously I'm not going to return that back inside. So inside that sample space. So that's why this is zero of replacement. So here is 11. Okay, so this is the answer for part A. Now part B, what is the probability that the first bulb selected is red and the second is yellow? So first red, and then after that we have yellow. Okay, let's write red and yellow. So first we have red, we have 30 in total. Then after that we have 29 in total. And how many reds we have is 12 red. And how many yellow we have is 10. Okay, so the answer is 0.138. Now part C, what is probability that the first one is yellow and second is red? So here is yellow. And second try, we have red. So in total, we have 30 here, multiplied by, here in total, we have 29 after choosing one. So yellow is 10. Red is 12. The answer is 0.138. Now part D, what is the probability that one bulb is red and the other one is yellow? So in between we have red and the other one yellow. What that means, we can have red and yellow, yellow and red, both of these, and we got the answer in part B and C. Combining these two is the answer for part D. So this is probability of yellow. It didn't say when we're gonna have red and when we're gonna have yellow. So that's why we may have yellow first, and then after that red, or we may have red first and after that yellow. Instead of and, I used comma. So that is equal to, this is exactly what we have here on part C. It's 10 over 30 multiplied by 12 over 29. You can directly add these two numbers. But I want to write these so you can see what we did. Here in between we have or is addition. So when you have or in between, you should add. When we have and in between, we multiply. Now for that part, we had 12 divided by 30 multiplied by 10 over 29. So this is 8 over 29. And the answer is 276. So 0.276, which is exactly that one. Add these two, we have this number is 0.276. Okay, I finished this part.